Have you ever looked up at the sun and wondered how much time we have left? I mean, I really thought about it. Because while you're watching this video, our sun is literally burning through 4 million tons of itself every single second. And that cosmic clock is ticking toward an endpoint that will fundamentally reshape everything we know about our solar system. But here's the mind-bending part. The timeline of what happens next is both terrifyingly precise and absolutely fascinating. Today we're diving deep into one of the most epic stories in the universe, the death of our sun, and the incredible journey Earth will take along the way. We're talking about a cosmic timeline spanning billions of years, with plot twists that sound like science fiction, but are actually scientific fact. From the moment our sun starts its final transformation to the ultimate fate of our planet, this is a story that will completely change how you think about time, space, and our place in the universe. And trust me, by the end of this video, you'll never look at a sunset the same way again. Right now, as you're sitting there watching this, our sun is in what astronomers call the main sequence phase. Think of it as the sun's middle age, stable, reliable, and burning hydrogen in its core like a perfectly tuned cosmic engine. This phase has been going on for about 4.5 billion years, and here's the remarkable thing. It's going to continue for another 5 billion years. 5 billion years. Let me put that in perspective for you. Modern humans have only existed for about 300,000 years. Our entire recorded history spans maybe 5,000 years. 5 billion years is so incomprehensibly long that it's 16,000 times longer than the entire history of complex life on Earth. So when we talk about the sun dying, we're not exactly dealing with an immediate crisis. But here's where it gets interesting. The sun isn't just sitting there unchanged during this 5 billion year period. It's actually getting gradually brighter. Every billion years, the sun's luminosity increases by about 10%. That might not sound like much, but it's enough to completely transform Earth's climate long before the sun actually dies. In about 1 billion years, just 1/5 of the way through the sun's remaining main sequence lifetime, Earth will become uninhabitable. The increasing solar radiation will trigger a runaway greenhouse effect. Our oceans will boil away into space, leaving behind a scorched, Venus-like world. And this is actually the first major milestone in Earth's cosmic timeline, and it happens while the sun is still technically healthy and stable. But let's fast forward to the main event. In approximately 5 billion years, the sun will have burned through all the hydrogen in its core. And this is where things get absolutely wild. When the hydrogen runs out, the sun doesn't just flicker and die like a candle. Instead, it begins one of the most dramatic transformations in the universe. First, the core starts contracting under its own gravity, which causes it to heat up dramatically. This heating ignites hydrogen burning in a shell around the now helium core. The energy from this shell burning causes the sun's outer layers to expand massively. We're talking about the sun growing to 200 times its current size. It becomes what astronomers call a red giant star. Picture this. The sun's surface will extend beyond the orbit of Mercury and Venus. From Earth's perspective, if our planet somehow survived this long, the sun would appear as a massive red orb covering a significant portion of the sky. The temperatures on Earth would reach thousands of degrees. Any remaining atmosphere would be stripped away, and the surface would be molten rock. But here's where the story gets even more dramatic. The red giant phase isn't stable. The sun will pulsate, throwing off material in powerful stellar winds. Over the course of about 1 billion years, it will lose roughly half of its mass this way. These stellar winds will create beautiful but violent conditions throughout the solar system. Now you might be wondering, what happens to Earth during all this chaos? There are actually several possibilities, and scientists are still debating which scenario is most likely. The expanding sun might completely engulf Earth, vaporizing it entirely. Alternatively, as the sun loses mass through stellar winds, Earth's orbit might actually expand outward allowing it to potentially survive the red giant phase as a charred, airless rock. Recent computer simulations suggest that Earth will probably spiral inward as it interacts with the Sun's extended atmosphere, eventually being consumed. But even if it survives, it would be utterly transformed, a lifeless, molten world orbiting a dying star. After about 1 billion years as a red giant, the Sun reaches another critical point. The helium in its core finally gets hot and dense enough to ignite in a process called helium flash. This is like a controlled nuclear explosion in the Sun's heart, causing it to briefly stabilize as what's called a horizontal branch star. But this stability is temporary. The Sun will cycle through periods of expansion and contraction, becoming increasingly unstable. It will experience thermal pulses, dramatic episodes where the outer layers expand and contract cyclically. During these pulses, the Sun will throw off more and more material, creating spectacular clouds of gas and dust around itself. Eventually, after all this cosmic drama, the Sun will exhaust its nuclear fuel entirely. The outer layers will be completely ejected, forming what astronomers call a planetary nebula, one of the most beautiful structures in the universe. These aren't actually related to planets, despite the name. They're expanding shells of glowing gas surrounding the dying star's core. And what remains of our Sun, the core, will collapse down to form a white dwarf star, an incredibly dense object about the size of Earth, but containing roughly 60% of the Sun's original mass. A teaspoon of white dwarf material would weigh about as much as a car. This white dwarf will be incredibly hot initially, over 100,000 degrees Celsius, but it will slowly cool down over trillions of years. Now here's something that will blow your mind about timescales. While the Sun's active life as a main sequence star lasts about 10 billion years, and its death throes as a red giant last about 1 billion years, the white dwarf phase lasts essentially forever. From a human perspective, the white dwarf will cool down so slowly that it will still be glowing dimly when the universe is trillions of years older than it is today. But what about the rest of the solar system during all this cosmic chaos? The story of each planet is fascinating in its own right. Mercury and Venus will almost certainly be consumed during the red giant phase. Mars might survive, but it will be heated to extreme temperatures. The outer planets, Jupiter, Saturn, Uranus, and Neptune, will be far enough away to survive relatively intact, though their atmospheres and moons will be dramatically altered. Jupiter's moons are particularly interesting. During the red giant phase, Jupiter will receive much more heat from the Sun. This could potentially make some of its moons temporarily habitable with liquid water on their surfaces. Imagine, billions of years in the future, as Earth becomes uninhabitable, some of Jupiter's moons might briefly become oases of warmth in our dying solar system. The asteroid belt will also be transformed. Many asteroids will be heated and altered by the Sun's increased radiation. Some might even experience volcanic activity for the first time in billions of years. The entire solar system will become a very different place. One of the most poetic aspects of this whole process is what happens to the elements that make up Earth and everything on it. When the Sun throws off its outer layers during the planetary nebula phase, it will enrich the surrounding space with heavy elements that were forged in its core over billions of years. Carbon, oxygen, nitrogen, the elements that make up our bodies, will be scattered into space. These elements will eventually become part of new star-forming regions, potentially contributing to new solar systems and maybe even new planets capable of supporting life. In a very real sense, the atoms that make up your body right now came from ancient stars that died billions of years ago, and they will continue their cosmic journey long after our Sun is gone. There's something both humbling and beautiful about this perspective. We're not separate from the universe. We're intimately connected to these cosmic processes. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged in the hearts of dying stars. But let's zoom out even further and consider what this means for the future of life itself. While Earth will become uninhabitable in about 1 billion years and the Sun will die in about 5 billion years, this doesn't necessarily mean the end of the story for life in our solar system or beyond. By the time these events occur, if humanity or our descendants still exist, we will presumably have developed technologies and capabilities that we can barely imagine today. We might have spread to other star systems, learned to harness the energy of entire stars, or even developed ways to influence stellar evolution itself. Some scientists have proposed incredibly ambitious engineering projects for the far future. For example, we might eventually learn to move entire planets to safer orbits, or even to relocate our solar system itself to avoid cosmic dangers. These ideas sound like science fiction now, but remember, we're talking about timescales that are thousands of times longer than all of human history. There's also the possibility that life might find completely new ways to exist during and after the Sun's death. The white dwarf that remains after the Sun dies will still emit some energy for trillions of years. Perhaps future life forms could harness this energy or find ways to survive in the very different conditions of that far future era. When we consider the timeline of the Sun's death, we also have to think about the broader context of cosmic evolution. 5 billion years from now, the universe itself will be very different. Our Milky Way galaxy is currently on a collision course with the Andromeda galaxy. This galactic merger will begin in about 4 billion years, right around the time the Sun is entering its red giant phase. This collision sounds catastrophic, but it's actually more like a cosmic dance. The distances between stars are so vast that individual stellar systems are unlikely to physically collide. Instead, the gravitational interactions will reshape both galaxies, eventually forming a single, larger galaxy that astronomers have nicknamed Milkomeda. Our solar system might be flung to a completely different part of this new galaxy, or even ejected into intergalactic space. If Earth somehow survives the Sun's red giant phase, it might find itself orbiting our dying star in the vast emptiness between galaxies. The timeline of the Sun's death also puts other cosmic events into perspective. Stellar evolution happens at different rates for different types of stars. The most massive stars burn through their fuel in just millions of years, while the smallest red dwarf stars can burn steadily for trillions of years, longer than the current age of the universe. By the time our Sun dies, many of the most massive stars that exist today will have already gone through their entire life cycles, some exploding as supernovas, others collapsing into black holes. Meanwhile, the smallest stars will still be in their infancy, with most of their lives still ahead of them. This creates a fascinating picture of cosmic evolution. The universe is constantly recycling material through stellar death and birth. The heavy elements created in dying stars become the building blocks for new generations of stars and planets. Each cycle potentially creates more complex chemistry and more opportunities for life to emerge. Our Sun represents just one chapter in this vast cosmic story. It formed from the remnants of earlier generations of stars, lived its life fusing hydrogen into helium and creating the energy that powers life on Earth, and will eventually return its material to space to contribute to future cosmic evolution. As we wrap up this cosmic journey, it's worth reflecting on what this timeline means for us personally. The death of the Sun is so far in the future that it's essentially irrelevant to any practical human concerns. The number of generations that will pass between now and then is almost incomprehensible. Yet there's something profound about understanding our place in this vast timeline. It gives us perspective on both the preciousness and the cosmic significance of our current moment. We exist during a brief, stable period in our Sun's life when conditions are perfect for complex life to flourish. Every sunrise and sunset you witness is part of an ongoing nuclear fusion process that has been powering our world for billions of years and will continue for billions more. The light reaching your eyes left the Sun's core hundreds of thousands of years ago, having slowly worked its way outward through the dense stellar interior before making the final 8-minute journey to Earth. When you look up at the night sky, you're seeing a universe full of stars at different stages of this same process. Some are young, hot, and blue, burning through their fuel rapidly. Others are old, cool, and red, approaching the end of their main sequence lives. Still others have already gone through their death throes and become white dwarfs, neutron stars, or black holes. Our Sun, currently middle-aged and stable, represents just one point on this vast spectrum of stellar evolution. But it's our point, the star that made our existence possible and continues to sustain us every day. The story of the Sun's death is ultimately a story about change, transformation, and the incredible scales of cosmic time. It reminds us that even the most permanent-seeming features of our universe are temporary, part of ongoing cycles of creation and destruction that have been operating since the beginning of time. So the next time you step outside on a sunny day, take a moment to appreciate the remarkable stability of our cosmic situation. The sun will rise tomorrow, and the day after that, and for billions of days to come. We are living in a golden age of stellar stability that has allowed life to flourish and evolve into the incredible diversity we see around us. The sun's death, when it eventually comes, will mark the end of one chapter in the universe's story. But it will also mark the beginning of new chapters as the elements forged in our sun's core spread out into space to become part of new stars, new planets, and perhaps new forms of life that we cannot yet imagine. In the meantime, we have billions of years to explore, discover, and maybe even learn to influence these cosmic processes ourselves. The universe is vast, ancient, and full of wonders we're only beginning to understand. And we're part of it all, made of star stuff, powered by stellar fusion, and connected to cosmic processes that span the entire history and future of the universe. That's the real beauty of understanding the sun's timeline. It shows us that we're not just observers of cosmic evolution, but active participants in the greatest story ever told.